In this video, I'm going to explain how binary numbers represent actual values and then do an example of adding two binary numbers together. And then we can take that with previous videos about how the hardware works to actually show how you would add two numbers in binary using the logic gates we built up. So you've probably seen maybe some binary numbers before. It's just a series of zeros and ones like this. And you've been like, okay, what the heck does that even mean? Well, the 0th bit here is multiplied by 2 to the 0 power. The first bit is multiplied by 2 to the first power, and so on. And this is actually no different from how our numbers work in the real world. It's just base 10 instead, the way we're used to. If you think about the number, 21, it's a really simple example. You're really taking 1 times 10 to the 0th power plus 2 times 10 to the first. 2 times 10 is 20, plus 1 times 1 is 21. And this is how we build up bigger numbers. Nothing's different in binary other than this base. So this is a 0, not a 6. It's not a very good 0, but you get the point. Well, we have 1 times 2 to the 0 is 1. So 1 times 1 is 1. Plus, we can ignore all zeros. 2 to the second is 4. So 1 times 4 is 4. And then sum is obviously just 5. Okay, simple enough. So how do we add two numbers? Well, it's actually basically the same as we're used to, but it might take a little practice. So let's just add 5 plus 6. And we know this is supposed to equal 11, and we can see that this number is 6 because we have 1 in the 2 to the first spot and 1 in the 2 to the second spot. So we have 4 plus 2 equals 6. So how do we add these? Well, we just add each digit together, and there'll be some carrying involved, which I'll explain. 1 plus 0 is 1. 0 plus 1 is 1. Here, 1 plus 1 is 2. And how do we represent 2? This is 2. So we actually put a 0 here and carry the 1 because we cannot represent the number 2 using one digit in binary. It's just the same as we can't represent 10 using one digit in our decimal notation. We use two digits. This actually happens to look like a 10. It's just a coincidence. So now we carry this 1 over and we bring that 1 down. 1 plus 0 is 1. Okay, now you look at this and do it yourself by assigning each digit a value, you'll realize that this equals 11. So clearly this is right. 5 plus 6 is 11. Okay, pretty simple stuff, but it's important to go over this so that in the next video I can go through the hardware design of how to actually make this work.